So, today I'm gonna talk about something very interesting because astronomers found 591 extremely fast stars. They're so called hyper velocity stars, okay? And you can see some pictures or videos, whatever, in the background. So, but what are hypervelocity stars? So hypervelocity stars, short HVSS, travel with such extreme velocities that dynamical ejection via gravitational interaction with a massive black hole MBH is their most likely origin. Observers have discovered dozens of unbound main sequence stars first since 2005, and the velocity, stellar nature, spatial distribution, and overall numbers of unbound B stars in the Milky Way halo all fit an MBH origin. Theorists have proposed various mechanisms for ejecting unbound stars, and this mechanism can be tested with larger and more complete samples. HVSS's properties are linked to the nature and environment of the Milky Way's MBH, massive black hole, and with the future proper motion measurements, their trajectories may provide unique probes of dark matter halo that surrounds the Milky Way. Yes, but now again something else which I really want to say to y'all. Yeah, in 2005, Smithsonian astronomers discovered the first hypervelocity star. A massive star whose 2 million mph velocity can explained only by ejection from the galaxy's massive black holes. So, from the massive black hole that's in the center of the Milky Way galaxy. This outcast star has been thrown out of the Milky Way galaxy and is destined to drift in the emptiness of intergalactic space. Symptosian astronomers are leading the discovery of new hypervelocity stars. Hypervelocity stars tell us about the types of stars orbiting near the central black hole and the history of stellar interactions with the central black hole. Yeah, everything about that. So now I wanna read or yeah, tell you one more thing about hypervelocity stars. So, weird hypervelocity star boosted out of Milky Way's disk. The monster black hole at the Milky Way's heart isn't the only celestial beast capable of boosting stars out of the way. A new study suggests astronomers traced the trajectory of a huge hypervelocity star backward through time. They found that the star known as LAMOST or Lamos HPS1 got its speed kick in the Milky Way disk, not near the galactic core where the supermassive black hole lurks, as had previously been suspected. A new study reports this discovery dramatically changes our view on the origin of fast-moving stars. Study co-author Monica Velluri, an astronomy professor at the University of Michigan, said in a statement. The fact that the trajectory of a massive, fast moving star originates in the disk rather than in the galactic center indicates that the very extreme environments needed to eject fast moving stars can arise in places other than around supermassive black holes, Valory added. So not only near supermassive black holes. Hypervelocity stars through space at speed, space through space at speeds exceeding 1 million mph, 1.6 million kilometers per hour, more than twice as fast as the normal cousins. These speedsters are pretty rare. Astronomers first spotted one in 2005 and have cataloged fewer than since then, but they found now more. Now they found over 591 of these hypervelocity stars. To reach their tremendous speeds, hypervelocity stars must experience a powerful gravitational slingshot. The chief suspect in most cases is Sagittarius A, the Milky Way central black hole, which harbors about 4 million times the mass of Earth's sun. But something else appears to be going on with Lamos HPS1, which is Earth's closest had known hypervelocity star. The exotic object lies about 42,000 light years from us. For perspective, the Milky Way's spiral disk is about 100,000 light years wide, so nearly halfway through the Milky Way galaxy. Valoria and her colleagues, led by the University of Michigan postdoctoral research Kouai Hattori, traced Lamos HVS1's path using observations made by Europe's Gaia spacecraft and one of the twin Magellan telescopes, which are part of the Las Campas Observatory in Chile. We thought this star came from the galactic center, but if you look at its trajectory, it is clear that it's not released to the galactic center, Hattori said in the same statement. We have considered other possibilities for the origin of the star. Hattori and his colleagues don't know how Lamos HVS1 got its speed boost, but they point out two main possibilities. The star may have had a gravitational encounter with multiple massive stars, or it may have been using slung out of the disk by an intermediate mass black hole within a star cluster. Lamos HVS1's apparent path originates at a spot within a Milky Way spiral arm known as Norma. No star clusters are known to exist in that location, the researcher said, but one could lurk there, hidden by dust. So Lamos HVS1's slingshot locale may be a good place to hunt for intermediate mass black holes. These mass objects whose mass fall between those of stellar mass black holes and those of supermassive black holes, so SPH, are thought to be more common through the Milky Way, but they have proved very difficulty to find or either study. Yeah, hypervelocity stars. Do you think that's a interesting topic? I really think that's something very interesting to talk about. And yeah, that would already be it for today's video. 7 minutes. Yeah. I think that's enough to explain hypervelocity stars. If you learned something, then I would appreciate a sub, of course, only if you learned something. So I hope you learned a little bit today. Maybe something brand new. I yeah, I don't think that everybody already heard of hypervelocity stars, but now you know. So thank you for watching and goodbye.